This is Statistics 243 for Friday, December 5th. Okay, so let's pick up where we left off last time. So let's gather together here. So we were looking at this graphic last time, and I think we discovered a number of things. Did anything else occur to anybody in the intervening time since we last looked at this? So the other question I was going to ask is how, we looked at this and we saw some sort of puzzling things here. So if we were to think about creating this graphic more from a scientific or a statistical perspective to illustrate some of the same information, what might we do differently with this graphic? What are things that we could do to rearrange it or add information or subtract information that would make this a better scientific or statistical graphic? What's that?
Clarify the gray.
Okay, so we could clarify the gray. What else could we do in terms of that would help clarify the gray?
Well, general point of clarification on the gray, but you made a really good point of it at the end about the U.S. versus the global and better differentiation of what that means and which data set is used for what part of the graph. I mean, I'm sure it's obscured for a reason.
Maybe. I mean, no. Yeah, I mean, it would be good to clarify, and if it is in fact that they're getting these numbers here by multiplying the U.S. proportions by the global total, that would not be good. And at the very least, it should be clarified. Let's come back to the gray a little bit. So we had this issue of like, well, is this 52 men or 52 male or 52 female? Is this 51 or 49 male or female? And then the fact that we sort of went from this to the, sort of what's the dividing line? How did they choose that 52 was the right dividing line between going from grouping in the gray versus grouping in the blue and the pink? What else could we do that would rearrange this, that would make that more clear? What's weird about the ordering here? Okay, I mean that's a choice that they could have ordered it based on this if they were more interested in the absolute discrepancy between male and female visitors versus the relative discrepancy. But even just literally in terms of how they did the grouping, what's kind of weird about this?
Do you mean just it's hard to compare directly across male and female? It's ordered differently.
Well, what do you mean by it's hard to compare? What would you be interested in comparing here?
They have like different websites for like males and females. Would you think?
Well, the websites are just I think these are just the websites that are whether or not people visited, right? I mean. Yeah,
it's just I think for me it would be better if they were like side by side or something, like more side by side comparison.
So you would want somehow for any given website you'd want a male and a female next to each other?
Something like that I think would be better.
Okay.
I
Mo?
think it will make more sense if like instead of say males they do like a percentage of 30 whatever percent, 40 whatever percent, and then they do like males and then put the equality in the middle and then females down there.
Yeah, that's sort of what I was driving at, and what I was sort of trying to draw out here is what's weird about this is they had to make this sort of awkward distinction between between the gray and the blue and the pink, and it's sort of that even up there that's not really in an order because we had the one female figurine and the two male figurines, and it was sort of flipping back and forth, and then we go from something that's close to equality here, something that's not close to equality, and then something back again to something that's close to equality, something that's not close to equality. So if I were doing this, I would be making a figure that was maybe putting Pinterest on the top, and then in the middle we'd have Scribd, whatever that is. We'd have Scribd, and at the bottom we would have whatever the most male-dominated one is, Reddit. Right? So this would be a continuous way of representing female-dominated in the middle, sort of not dominated either way, to dominated by males, and then you wouldn't have to make this distinction of exactly do I go from pink to gray when I go at 48 or 52, or it would just naturally emerge from the ordering, and you could then decide for yourself, well, 55, 45, that's sort of more or less equal, but then if I start to see 70, 30, that seems very unequal. Right, so I think that would be a much more natural ordering here. Maybe it wouldn't be as visually sort of drawn out, because maybe you then not have the blues and the pinks and whatnot, although personally I think that would probably be an advantage. What else could we add on here if we were thinking about this scientifically? Yeah, Eugene?
Well, I still think the idea of number of percent over 50.
Well, okay, right. So that's good that you brought that up again, because I remember you said that last time. I mean, if we had it this way, we could still if we're doing it this way, we probably wouldn't do it as percent over 50. We'd probably do it as the actual percentile, either male or female. So let's say we did it as percentile female. We'd have some bar for Pinterest that looks like there and this, and then for Reddit we'd have a bar here, and then for ScribD we'd have one that was right in the middle at 50%. And I think that would be a more natural way to do it as well. Anything else we could do with this? Think statistically. If we're statisticians, what can we add on here?
Sorry, isn't the article trying to get at like matriarchy? So it's like trying to show that the pink is actually more than the blue. I thought that was the point of it.
Oh, I thought it was just trying to show that some were dominated by. Oh, I guess it is saying chicks rule. So, I mean, but if we sort of look at the data, there are a number of sites that are dominated by women visitors and a number of sites that are dominated by male visitors. So in some ways, to me, the title doesn't really match the results in some sense. I mean, I think they're just saying chicks rule just as a way to have a title sort of getting at this question of gender balance. What's that? Oh, in terms of the total more visitors? Yeah, maybe they're drawing out that in total more people are visiting websites who are female than male. I'm not, yeah, that's an open question.
It's just because Facebook has such big negative.
Yeah, I mean, right. Again, there's a question here of are we interested in the percentages or are we interested in the absolute numbers again as well. All right, so one more thing I want to draw out here. If we're thinking as statisticians, what is missing here that we could put in here? Yeah, where do these data come from? Is there uncertainty in these? Are these somehow like they actually got the is this based on a survey, in which case we could put error bars in here? Or is this based on actually going to YouTube and somehow getting the data from Google to say, we actually know exactly how many visitors that they had in a given period? So I don't know if this is sample-based or if this is actually the full population of visitors. But if it's sample-based, it would be good to have uncertainty on here. And that would also help get at this question of, well, you know, is Foursquare really, you know, that it's somewhat more, a little bit more male than female, or is that just within the range of sampling variability here? All right, anything else anybody wanted to mention? All right, so let's move along from here. I wanted to bring up a few more graphics from this paper by Howard Weiner. This is really old, so you're going to look at these graphics and sort of laugh, just in terms of their sort of visual typesetting quality. But I think they draw out some useful things. This is from an article in the American Statistician in 1984. But one thing I want to draw out by looking at a few of these examples, we won't look at all of them, is that part of the goal when you're making a graphic is to try and figure out for yourself what point are you trying to make. What contrasts in the data are you trying to emphasize? What groupings are you trying to emphasize? What sort of oftentimes we're going to have data that you could sort of look at from different perspectives, and you can't actually have the graphic focus on all of those perspectives at once. And so you may need to choose sort of which thing you're highlighting, and that may draw out, you know, how do I choose which colors to use? How do I choose what ordering to use? How do I choose what the magnitude on the axes are? All of those questions, answering all of those questions may in part come from what you want to say with the graphic. So let's look at a few of these. So one example is here. So this is a graphic. Well, is this the one I want to highlight? No, let me move on to a different one. So here's an example. It says this is something about the number of public schools in different years. So this, sorry about the quality. This is 1929, 49, 1969, and this is, I guess, the number of public schools in the white bar and the number of private schools in the black bar. I presume this is probably in the US, I'm not totally sure. But if we look at this, we can there are some things we can make out from this and some things we can't. So one thing we can obviously see is we can see this decline in the number of public schools, which probably has to do with schools getting bigger and like one-room schoolhouses closing and things like that. But we could also say, well, what is this also? So this shows the magnitude of this shows, we can easily see the decline in number of public schools. And we can easily see that in all of these time periods, the number of public schools is much greater than the number of private schools. But because of the scaling and the fact that we're presenting the public and the private on the same scale, it's really hard to tell whether there's been a time change in the number of private schools over time. So if one of my points in this graphic were to say something about how the number of private schools has changed over time, this is not going to be a very successful graphic to draw that out because of the way that I've laid this out in terms of the axis being, the scaling being dominated by the public schools. So you'd have, that might not be the main thing the person wants to draw out, but if it were, this doesn't do a very good job of doing that. This is actually the authors redrawing that to say, well, if we looked at this, it's pretty hard to tell how this black bar here compares to this black bar, except we can sort of, if we look closely, we can say, oh, that seems like it's increased. It's not a huge absolute increase in terms of what we can see on the scaling, but it seems like it might be a pretty big relative increase. And if you actually go and then plot just the private schools, you can actually see it is actually a fairly big increase. It goes from 9,000 here all the way up to 14,000 here, so an increase of almost something like 50% over time. Yeah.
This is quite a bad graphic in itself because it's like going from 9 to 50.
Yeah, so that's a good thing to point out too. Is these graphics where you put this little discontinuity in here is often kind of deceptive because it looks like it's increased by a factor of like 5-fold if you just compare the how far it is from here to here versus how far it is from here to here. But in fact, you have to look at the axis and see, well, it's just going from 9 to 14. So it's a big increase, but it's not as big as it might seem by how it's been drawn. So yeah, I think that's a good point. And in general, you'd probably want to avoid doing this sort of thing if you can. In some cases, it might or might not be possible. One other thing, I'll just actually show an example here since we're looking at that bar chart with the private and the public schools, which is bar charts often don't do a very good job, at least when we stack them like that, of actually being able to see changes across the x-axis. So I'm hoping this will. There we go. Sorry, this is again my usual problem with RStudio. All right, so forgive the. Well, let me just do this in R. Okay, that's better. So here's a stacked bar chart where it's saying something about death rates by different groups of people: males living in rural areas, female, rural, urban male, urban female, and by different age groups. But if you're trying to do a comparison across the different categories, you can easily see, well, you could see that the death rates, I don't even know if it makes sense to add these death rates now that I think about it. Maybe it does. You could, for example, see that the total death rate among rural males is higher than among rural females. And you could even see that if you wanted to look at the 50 to 54 category, you could sort of see how high these are relative to each other. But now if we try and compare across one of these other categories, we're forced to sort of figure out how big this is and then sort of compare it to how big this is. And they're starting at different places. So sort of stacking the bar charts like that makes it hard to see these contrasts across the x-axis direction. So these are often not a great way to display things. One possibility here would be to do side-by-side bar charts. And in this case, I guess I'll do it again just in plain R. Where is it here? Oops. So here, if you were interested in comparing any one of these groups across, it's going to be easier because they're all starting at 0 to then compare the heights of the bars within a category across the different. To compare the heights of the bars across the different categories. All right, let's go back to the Wayner one, see if there are any other things I want to draw out here. So, okay, so continuing with this theme of sort of what are you trying to get the reader to focus on when you're presenting a graphic? Here's an example of somebody, I think, doing kind of a poor job of this, which is, this is some sort of information about US imports and exports to China and Taiwan. Again, this is really old data, but that's sort of not the point here. And if you look over here, what do we see? We see, well okay, so why am I pointing this out? Like, what's weird about this graphic? Okay, well that's one thing. Yeah, I guess this sort of looks like a line plot, but then it also looks like sort of a, not really a bar chart, but sort of a filled-in, weird filled-in bar chart. And so they've done something weird with the white line to make sure you can still see this, but it's not. Maybe because they want to sort of emphasize the white versus the black, they thought filling in the black would be a good idea, but maybe that wasn't a great choice. Anything else odd about this one? Yeah.
Y-axes are different.
Yeah, so this goes from 0 to 3,000, and that goes from 0 to 6,000. So oftentimes, oftentimes a reader is not going to catch that unless they look pretty closely, and this is going to be deceptive. I mean, in some cases you can't get away from it because things are just on totally different scales. But in general, if you've got multiple panels within a plot, you want all of the axes to be on the exactly the same scale. This is something, I think I've said this to every grad student I've ever worked with. They bring me a plot to look at. I'm like, those axes are different. It's hard for me to compare from one to the other because my brain has to do all the work of like, oh, 3,000 here means 3,000 there, and 6,000 there. Well, that's way up there. You have to. Your brain. It's just a lot for your brain to process in addition to what the graph is trying to draw out. The other weird thing here is that it's swapped the. I guess it said that here, reversing the metaphor. It's turned the black, which were imports from China, into exports to Taiwan here. So it switched the imports and the exports, which wouldn't be a great idea. I mean, maybe the person who was making this was trying to make some sort of trying to focus the eye in some way, and they chose that deliberately. But it's not totally clear to me why they did that. Okay. Let's see what else I want to point out here. Here's another example of how areas. It's a bad idea to use areas to show differences in magnitude. So this is supposed to be. This is supposed to be something about inflation, that $1 under the Eisenhower administration in 1958 was worth more than $1, for example, during the Carter administration. So $1 under Eisenhower buys 44 cents under, wait, what is this? Is that reversed? So basically, what is this? So if you had $1 under Eisenhower, that would buy you a lot more under Carter. So if you have Huh?
It's the future value.
Oh, it's gone the other way. Okay, thanks. Okay, so right. So this was under Eisenhower, $1 was worth $1, and then the current purchasing ability of $1 under Carter is only 44 cents. Thanks. That was sort of, my brain was trying to go the other direction. So of course, if you look at this and you look at Carter, if you look at it in terms of this looks much smaller than this, and so the area, we're sort of having to interpret relative areas. It's not totally clear to me. Yeah, so I mean, if it looks, actually, I'm not sure what they've done here, because this is actually not 44% of the area of this. It's less than half much less than half of the area of this. So what they might be doing is they might be asking the reader to compare lengths. So maybe this is a length of 44 relative to a length of 100 up there, except then because of the fact that they've shown rectangles, then it's hard for us to know exactly what they're doing. So a less flashy but more honest version of this graph would actually just be to do a plot like this, where you say, okay, here's the y-axis. I can actually plot what the values are, and then it's much easier to see. This is actually 44, and it's about half as much as the 100 from the earlier time period. All right. Maybe one more here, just to hit on this idea of sort of what do we want to focus on. So this is a graphic that somebody made. See if I can blow this up a little bit. Okay, so this says median income of year-round full-time workers 26 to 34 years old by sex and educational attainment, 1968 to 1977. So on the y-axis is time. So what have they done? They've put on the y. They've got a few different dimensions here. They've got time. They've got male versus female. That's the two subplots, and they've got educational attainment. So they're trying to display how something varies in 3 dimensions, and they're trying to figure out how to get that all onto one graph. So what have they done? Well, they've chosen to split the males and the females into distinct graphs, and then they've chosen to split the educational attainment into different line types. And so what can we easily compare here? Well, we can easily compare, what's really obvious is the fact that people with higher educational attainments are earning more. So that comes out really clearly in the plot. And we can pretty easily see what's happening over time, that in some cases there seem to be some time changes, in some cases there doesn't seem to be that much time change. But what's pretty hard to see, and that what the graph doesn't draw out at all, is what the relative earnings are of men versus women, because to make that contrast, to make that comparison, you have to go between the plots. And in fact, actually, here's another example of where they have a different axis scaling on one plot versus the other. So you have to look and see, and your brain has to do the work to say, oh, women are at around 12,000 at 16 years of educational attainment. Men are at something like 18,000 or 16,000. So there's a big disparity between men and women there. This is older data, so that's not even less surprising than it would be today. But if that were, the point of the graphic to distinguish between men and women, it's not. This is not doing a very good job of drawing out that contrast. Whereas it does seem to be focusing on this time change and on the differences in educational attainment. So if instead you were trying to draw out the male versus female distinction, you would probably plot this much differently. Here's an example where the authors replotted it to draw out that distinction. And here they actually chose to change the y-axis to be years of educational attainment, change the line plotting to be men versus women, and they're sort of not focusing very much on the time change. I think the time change is just sort of captured in sort of the spread of these points here. But another illustration of you've got this, you're trying to plot this result as a function of 3 dimensions, 3 input variables. What is it that you're trying to emphasize? You have to choose how you're going to choose the plotting scheme. That's going to vary depending on what you're choosing to emphasize. Anything else I wanted to mention here? There are some other examples that are sort of similar here. I like this one. I don't really have a point to make here except a point against 3D bar charts. But I'll show you this one here. So this, I'm not sure, I can't really show this. So this says earnings per share and dividends. So it's some sort of financial data. And then it has both earnings and dividends. And the caption is, an extra dimension confuses even the grapher. So if you look at this, you can sort of see what's going on. Like, what's going on? There's no 1978. And then you look a little further and you realize there's a number here. They've sort of lost the additional part of the bar that goes here. And so they have numbers that go up through here on the top part, and then they have sort of an extra number for the bottom numbers, where it looks like maybe they just duplicated these numbers. Maybe it was some sort of typographical error. So obviously people make silly graphics all the time, but this one did actually appear in the Washington Post apparently. So it got past a bunch of editors. And obviously here the 3 dimensions really adds nothing to the plot at all. Okay, so I think that's all I want to say about these examples. So I have a few things. We don't have a ton of time, and there's a whole bunch of stuff in the graphics unit. So basically, in part, I prepared this just as a resource to you guys. There's a bunch of demo code in the unit 15-graphics.r file, both on base R graphics and on ggplot and the other one. What's the other graphic? Lattice. So maybe I'll just hit a few examples here, and if you are interested, you can run through some of the demo code on your own, or you might end up coming back to this in the future if you're looking for how to do something specifically. So one comment is, as I think many of you know, when you're creating base graphics in R, you can basically layer a bunch of things on top of each other. So let me just show you an example of that here. Okay, so here's an example where I'm going to actually exclude some of the information from the graph when I first plot it. So here's a graph where, because of some of the plotting parameters, the plotting arguments that I passed here to saying don't add a box, don't add a y-axis, don't add the y-axis information, you can see that the plot is basically missing some stuff that would usually be there. There's no y-axis, there are no tick marks on the y-axis, and so on and so forth. So when you're plotting, you can build these things up in pieces. And just to see an example of sort of adding in some of these pieces after the fact, here I've just added in a box by calling the box. Here I can add in an axis separately from having done the initial plot. So here I added in the y-axis information, and I chose to add it in blue. For some reason, it sort of only adds it in. It only colors part of it. It didn't like add in the whole thing, which is. I've come across that before. It's sort of not ideal. Another useful thing you can do is if you use the new argument to the par command, you can now do additional plots on top of the original plot. So I could, for example, do par of new, and then I could actually create a whole new plot and just basically plot on top of my old plot. And this in some cases can come in handy. This is just sort of a silly example. But here I went in and added in the red points. I could have just done this with the points argument without doing this new equals true. But just to illustrate that I can add additional stuff into a plot afterwards and actually recall something like call the plot command again and just overwrite on top of what already existed. And I can do things like add an axis on the right-hand side as well. So there I'm adding an axis on the right-hand side. Or maybe I wanted to add a rug plot just showing where the data values are, but on the axis. So I can add a rug plot, and side equals 4 is the right-hand side. So you can see, it might be hard to see in the graph, hard to see in the back. It added in little tick marks to indicate where the red points were on in this dimension, sort of collapsing onto the axis. So that can come in handy, particularly like this. Something like this would have come in handy with the public-private school example. Like you could potentially have plotted the private school data referring to this axis, and you could have plotted the public school referring to this axis and the private school referring to this axis, and use two different scalings in the same plot. Any questions about that? Let's see. Another thing that's useful, I was starting to draw it up over here, is just to know what some of the dimensions are in these base graphics, and what some of the arguments that you can pass to par refer to. So if you have a plot with multiple panels or subplots on it, the outer margin, which I've sort of indicated in the dashed lines, the OMI parameter will determine how big this outer margin is in each of these four, on each of the four sides. And so OM stands for outer margin. This stands for inches. If you want to pass in how many inches should be in each of the margins. And the inner margins of the individual subpanels you can specify with MAI. And I use this a lot because oftentimes the base graphics, especially when you print a PDF, you'll end up with this little tiny figure, and you'll end up with a ton of white space. And so it's handy to be able to manipulate MAI to basically reduce this white space around each of the subpanels in the plot. And you can do that by passing in a vector of 4 values as the MAI argument to par. So here's the first one indicates here, second, third, and fourth indicate the 4 different dimensions, or 4 different sides of the image. And then I don't actually use this all that often, but if you're interested in, if you wanted to know what if you look in the help on par, you'll also see information about FIN and DIN and PIN. And so FIN is basically the size of the sub pieces of the plot in this direction and this direction, so this is a 2-component vector. DIN says how big the overall plotting is, and PIN says how big the panel, the plotting window is within each of the subpanels. So sometimes it's helpful just to sort of, I thought I'd just show this just all at once because it can be helpful to sort of see it all in one place. And then the other thing that will come up is oftentimes these are, usually when they end in I or in IN, they mean they're in inches. Sometimes you can also specify it in terms of the number of what are called units of lines, which is a little bit weird, but the lines unit is basically that if you have a plot, sometimes if you're adding text to the plot, you can tell it what line to do it on. And so this is the first line of text, this is the second line of text, this is the third line of text, and there's sort of a height associated with a given line, with a given unit of lines. So you can also, instead of specifying, for example, instead of specifying MAI, which is in inches, you can specify MAR, and this is in units of lines. So basically, how many lines of text do I want in terms of my spacing between the subpanels? So a lot of these can be specified either in terms of inches or in terms of this sort of funny unit of text lines. All right, any questions or comments? Let me see, so I don't have too much more time. Let me see what other highlights I want to hit here. One other thing that sometimes comes in handy is sometimes, like with using par and then the MF row, you can easily specify a rectangular arrangement of subpanels or subplots. Sometimes it's actually helpful to be able to have a little bit more control over that. And so here's an example of doing that using the layout function. And so basically, the layout function, you pass it a matrix like this. And what this matrix in this particular case says is, in the first row, I should have one panel that takes up all of these sort of four potential subpieces. And in the second row, and I'm going to call that one the first panel. And then the fourth panel is going to be this one, and the third panel is going to be this one, and the second panel is going to combine these two potential subpanels. So I can basically sort of rearrange the squares and sort of consolidate subpanels. And then if you wanted to plot within those, here's an example of doing that. Okay, so here I plotted that, the first one plotted in the first subpanel, the second one should plot in the second subpanel, and then the third and the fourth should plot in the third and the, okay, usual RStudio difficulties. Okay, all right, this would work better outside of RStudio. The world's worst histogram. But hopefully it illustrates the point. I made one panel that was spanning all four of the potential subpanels. This one's taking up this half, and then I have two smaller pieces in here. And there's also something called split dot screen that allows you to do somewhat similar things. Okay, I don't have much time to go into really any details on ggplot or on the lattice package, which are sort of two of the other common ways of making plots in R and are particularly popular these days because they sort of provide a nicer interface than the base graphics. And a number of you who were at the boot camp in August saw a bunch in terms of ggplot too. But I will just point out that in some ways there's sort of a similar theme with ggplot2 that, so I'm down in the section 3.1 of the demo file. So let's go back to the PDF. That you basically create ggplot2 plots in a similar sort of layering manner, that you're sort of starting with a base graphic and then you're layering stuff on top of it. So the syntax that you'll see is you'll call it ggplot, you'll give it the data set, and then this aesthetic argument basically says what are the x and y and the potentially z variables. And then you'll add on with pluses a whole bunch of calls to particular plotting functions that will plot particular stuff onto this sort of default basic graphic. And so this idea of layering stuff on is a common thing for ggplot2. And so an example of that is, here we're saying we want to plot using the USA data set. We want to have year or time be the x-axis, and something called v-turn be the, I think that's voter turnout, be the y-axis. And then here we're adding in, we're saying that the kind of plot we want to make is to make a plot of points. But in this case, we're actually going to plot black points, and then we're going to plot red points that mean something else. So again, we're sort of layering pieces of information onto the graphic. And so you get something like that. And similarly, if you were wanting to make a bar chart and add error bars on and then add a title on, you can do that basically in pieces where you construct you basically say, make a basic plot, now put the bars on it, now put the error bars on it, now put the title on it. And in this case, I actually created a whole second subplot as well. So I think maybe the last thing I'll mention is just a little bit about color and color schemes, which sort of goes back to this idea of what are some good principles in terms of graphics. So actually, before I do that, how many of you are familiar with the difference between vectorized and rasterized graphics? Okay, just a few of you. So maybe I'll pause there and mention that. So if you have either a PDF or a PostScript plot, those are what's called a vectorized format, and that basically means that the objects in the graph are represented as points and lines and sort of geometric objects. And what that means is if you take a graph, say, as a PDF, and then you basically zoom in or scale out from that graph, those lines and points will scale naturally and you won't have pixelation and things like that. Whereas if you have a rasterized file format, that's basically a format where the plot is just represented as pixels and color, and the amount of color that's plotted in the particular pixel. And so the result is when you're working with rasterized formats, which are things like JPEG or TIFF or PNG or formats that you would associate oftentimes with photographs, those things are really just represented as pixels. If you zoom in or you scale out, it's often gonna be pixelated, and it's not going to scale very well because you've basically saved the image at a fixed resolution, and that doesn't allow you to resize things very nicely. So just as an example of that, I think I create both a PDF and a PNG in here at some point. Okay, so I'm going to write out both a PDF and a JPEG file, and I'm just plotting the exact same things on these two files. So let me figure out where this is. Okay, so here's the PDF. And if I go and zoom in, you can see I can sort of zoom in infinitely far, and this is still incredibly clear, right? Actually, now I'm curious how far I can go in. I guess that's about it, at least in terms of this viewer. Okay, so on the other hand, if I open up the JPEG file, I'm not sure if I can do that in this viewer or not. Hopefully I can. Okay, so here's the JPEG file. It's saved at a particular resolution. If I zoom out, all right, so this doesn't look bad, right? I've zoomed out enough that the sort of natural resolution which this is saved at, I can sort of view it like that. But if I try and now zoom in, you can see that it's pixelated. And you can actually see the individual pixels that this thing was saved as and is being plotted as. Right? These are the individual pixels that make up the red line in the plot. Right? So you're limited in terms of your ability to really zoom in and see what's going on. So in general, it's often a nice idea to plot, particularly if you're dealing with sort of naturally vectorized graphics where you have lines and points and letters and words and stuff in it. It's often a nice idea to use either PDF or PostScript as opposed to using something like JPEG or TIFF or PNG or something like that. One downside to that is that if you have a ton of points, you can actually end up with very, very large files. So if I were to plot like if I had a scatter plot of like 1,000,000 points, and I tried to do that as a PDF, I would see that I had a file that would be like 10 megabytes or 20 megabytes or 50 megabytes or something like that. And that's because it's basically saving every point as a piece of information. Whereas if you had saved it as a rasterized format, it would just basically have the color for each of the pixels at whatever resolution you saved the file at. And so you could save it at lower resolution and not have it be as large a file. But in many cases, it's a good idea to just do it as a PDF. And then I guess the other thing I'll mention along these lines is, since I'm talking about having lots and lots of points, is oftentimes if you have a big data set and you're trying to plot a scatter plot that has a lot of points, you'll end up with a plot that looks like this on the left. Oops. Right, where you basically, all of the information about how dense the points are has gotten lost in the fact that you've got all this overplotting of the symbols. So you could, for example, try and make the points smaller, and maybe you wouldn't use something that has a white circle or isn't a black circle with a white interior. But eventually, if you have enough points, even using smaller sizes of the points is not going to work very well. So I won't go into the exact packages and the R commands to do this, but there are a couple different pieces of functionality in R where you could basically plot something like this, but instead do it as sort of as a scaling in terms of the density of points. And this is using some transparency. So basically, it's plotting individual points with as a fairly light color, and then the result is when plots get pointed on top of each other, you end up with this darker effect when you get a lot of points in one area, in one local area. So you can get a better sense of the density by having this transparency and having the lighter color for each of the points. And then you can also do things like this. This is from the hexbin package, where it actually plots hexagons where the color of the hexagon varies with the number of points that fall in that hexagon. So that's kind of a nice thing to do. Yeah. And then I think I'll leave you with a little bit about color schemes. So if you are using color like in an image plot to represent if you have X and Y dimensions and you're using color to represent the third dimension, it's useful to think about what color scheme you want to use. So I guess this is down here in sets in number 7. Somewhere in here. So here I'm just plotting sort of simulated or garbage data, but I'm going to do it in 4 different color schemes. All right. I thought that the other problem is I thought I was making 4 plots here. Oh, that's weird. I thought maybe I left out I guess I left out the 4th of these plots somehow. Yeah, okay. All right, so forgive the terrible aspect ratio and the terrible white space issue here. But if we look at these 4 plots, this is the same data plotted with 4 different color schemes indicated by the 4 different legends here. And so you can sort of think about what are natural color schemes and what would do a good job in representing the particular data that you're interested in representing. So if we look at this one, this is, I forget which one this is. I think this is rainbow dot colors. So if you look at this one, what's the downside of plotting it like this? Yeah, there's sort of, it seems like it's starting to sort of wrap around from here to here. So if I'm trying to see what's hot, what's high and what's low here, there's a reddish color up here and there's a reddish color down here. And so it's hard to know. If I just look at this, I have to do a lot of like, oh, well, that's purple here, so this red probably means it's the high red and not the low red, and things like that. There are other cases, this is maybe not too bad an example, there are other cases where you'll see somebody making a plot with a color scheme where the ordering of the colors goes in no particular order. It like goes from red to purple to yellow to blue to green. And you have to look and you're like, this is a continuous scale of numbers. But then you have to be like, oh, yellow is bigger than red and red is smaller than purple. And you have to sort of do all that. Your brain has to do all that work. This isn't, except for the wrapping around, this isn't too bad. This is something called tim dot colors, which is in the Fields package, and the one that I like. And this sort of has a natural ordering of sort of blue to green to yellow to orange to red. So this is kind of a nice color scheme that you can use. On the other hand, if you really are centered around 0 and you've got sort of negative values and positive values or some natural middle point, one nice thing to do is just have the middle point be something like white, and then have one increasing color in one direction and the other increasing color in the other direction. And then you know, blue is low, darker blue is even lower, red is high, darker red is even higher, and white is sort of in the middle. So that can be natural if you've got this sort of natural midpoint and you're sort of emphasizing positive versus negative, or above the median, or above the mean or median versus below the mean or median. And then you can also have sort of more of a color scale where you're sort of only using a part of the color spectrum, and you're going from sort of whitish to dark red, but just passing through yellow without sort of passing through all of these other kinds of colors. Okay, so that's all I have for you. I hope you guys have gotten out of the class what you wanted to get out of it. I know you guys put a lot of work into it, so I hope it's been worth your while, and thank you for participating. I have old problem sets from a few of you. So Florian and Thibault, I think I have some of yours. Anybody else who showed up a little bit later? Oh, the other thing I was going to say is, if any of you in the future, have questions or want to talk to me about stuff, outside of class, I have an open door, particularly since I now know you all and you've taken my class. So feel free to come by if you have questions you want to chat about. Is Lindsay here? Okay, see ya. Hey Guang, you're friendly with Kevin, right?
Yeah.
Will you take a few old homeworks to him?
Look at him skipping class. He should take some points off his own.
Is it? Great, thanks. Those are yours. Actually, you're friendly with Aurelian, right? Yes. Okay. Will you see him? Okay. I'll give you his too. Oh, Guang. I have one more for you. I might have one more of Aurelian. So. Thanks, appreciate it. Okay.